Hi all, in this demo we are going to see how to translate and rotate about a specified vector, meaning it doesn't have to be in the XYZ origin basics axis, it can be in a different one. So let's look in for example, we have the translation conversion here. So here we have the x2, z2, and y2 axis. We can see them in red, green, blue. We have the original xyz axis. Y is here, z is here, x is here. And we have some 3D object. We can see the cuboid, the original one. And we can see that it was translated with respect to the x2 axis by the value that we have given to it. We can do the same for the Z2, Y2 axis. So this is the translation. Let's look at the implementation, which is relatively simple. All we have is we get a new axis and we simply multiply it. This is a scalar. So all we have to do is just to multiply the scalar of the value of the movement with the new axis, and that's it. We got the translation vector in the original x, y, z basic vectors. It's relatively simple since the xyz will produce the identity matrix. So this is the translation. Let's look at the rotation. Now rotation, it is a bit more complicated. So for that we will use the Rodrigues formula. Not that file, it's the convert rotation to okay. So here we are rotating 60 degrees about the x2 axis. So we have several axes. The original axis, well, we have the basics axis of the x, y, z, and we will get the values, the rotation matrix of the x, y, z that is required to rotate about the specified axis of we have here the x, y, and z. Okay, and this will produce the x3, z3, and y3. Okay, the one that are not dashed are x2, y2, z2. So what we did here is we rotated 60 degrees around the x2 axis. Now, since it was around the x2 axis, we can see that x3 overlapped it. Okay, and we can see that we have 60 degrees of movement from y2 to y3, x2 to x3. Let's repeat the same process and this time rotate about the z, and let's do it by minus 45 degrees. Okay. So we can see that the z3 is indeed overlapping z2. Let's look from an angle where we can see it. Yeah, we can see that the rotation is to the opposite side since it was a minus, and we can see that it is in the middle here, for example, meaning from the green to the red we have 90 degrees. We can see that it is indeed about 45 degrees. So let's look at the implementation. The implementation is by the Rodrigues formula. And we have it here in this function x anc to rot m, which has the full implementation here, and we have here only a basics operations here that can be implemented in any language. So we have the axis and the angle. Here we chose to create four um, four elements vector that the first three are the axis, and the fourth is the angle. We verify that it is normalized, and we normalized it otherwise. So now we have u1, u2, u3, which are the x, y, z values of the axis that we have in hand. We have ct, which is the cosine of the angle, st, sine of the angle, and vers t, which is 1 minus the cosine of the angle. Now this is exactly comes from the Rodrigues formula. You can see the Rodrigues formula here. And here we have the 9 elements of the rotation matrix, 3 on 3. So the first one is u1 times u1 times vers t plus the c of t. So let's see that we have u1. Yeah, we got it. Okay, so it's simply, now note that here it's vector multiplication. We can debug it. Yeah, okay, so let's look at u1. Oh, it's a scalar. So it's just the first. Yeah, u1 is just the first value of the vector. So we have here scalars. So all we see here are just scalars, meaning that if we repeat the step again, let's go and see it. We have it. Yeah. Okay. So u1 is just a scalar, and so we have scalar times scalar. This is scalar vers t, which is 1 minus c of t, and plus the what we reduced. Okay, so we have the plus of the ct of the cosine. Yeah. Okay, so this concludes the required steps to apply the Rodrigues formula.
It's like quaternions do have this nice property.
Now we can look at it from, check this formula. Okay, we have here the matrix. Yeah, we can see it. So minus k z, and we can find the corresponding values in the MATLAB for each one. Okay, it will be in agreement to what we see here. So one can find the reference to Rodrigues formula in order to understand this basic code. But no, this code has only basics operations, and all we see here is just scalars. Thank you.